Recording is on. Welcome to SQL Friday, episode 11. Today's star is Torsten Strauss, who is going to present performance tuning with optimistic concurrency. He has labeled it as a level 300. I don't know if that is 8 KB level or Microsoft levels, but I guess you will touch on it on the intro to the session yourself. And how much of a headache will we have trying to follow along? I'm looking forward to it though. Please mute your microphones if you're not Torsten. And if you have any questions, post them in the meeting chat and I will relay them to Torsten as it fits during the presentation. Yeah, and like I said, this is SQL Friday number 11. So we've done 10 before this. We have a schedule which is, I think it's becoming pretty impressive, and I just decided that I will do SQL Friday next year as well, starting somewhere in January. So keep an eye open for the call for speakers if you are a speaker. I'm not going to say much more. Welcome, Torsten. The stage is all yours.
Okay, let me try to take over. Desktop. Would be good if you tell me that you can see the screen.
I do not see it yet.
Oh, really?
I just see, maybe it's me.
Let me try to share again.
Now it's coming, I think.
Okay, perfect.
We'll give it another, yeah, now it's on.
Yeah,
perfect.
Okay, perfect. So that is me. So my name is Torsten Strauss. I'm consultant, trainer, and speaker. I'm also Microsoft Most Valuable Professional, and I have some certificates. It is not that important. Just to remind you who I am. That's it. So yeah, let's start with the session because that is why you are here. Let's talk a little bit about optimistic and pessimistic concurrency, and especially the optimistic concurrency is the one we are talking about. So first of all, you have to understand that SQL Server always have to log resources whenever the database is not in read-only mode and when you have more than one user on your database, which is obviously or almost always the case. So when we talk about logging and when we talk about a transaction isolation level, we talk about the ACID rule. So the ACID rule, as you can see, is defined here. And whenever we talk about transaction isolation level, we will talk about the I of ACID, which is isolated. And the isolation property ensures that the, I would say, concurrent executions of transactions result in a system state that would be obtained if the transaction were executed serial, that means in row, so or after one after the other. So this is just a quick introduction about logging and blocking. I had a recording with Century1, so it is a 4-hour recording, and there's another part planned. So if you want to learn more about logging and blocking overall, you should go to Century1 in order to listen to the recording. Nevertheless, let's talk a little bit about the concurrency model. As mentioned already, we have a pessimistic and an optimistic concurrency model. And in a pessimistic concurrency model, readers always block writers and vice versa. And writers will block writers. That is something which is common when we talk about optimistic concurrency model. So in an optimistic concurrency model, readers do not block writers because of row versioning, and we will talk about row versioning, and vice versa. But writers still blocks other writers. And I can see this to delete here. So the main difference is that whenever you read a resource in an optimistic concurrency model, you do not block writers and vice versa. That is the main difference. And that is something which is pretty handy when you talk about, when you think about busy database, busy OLTP system, where you have a lot of reads and a lot of writes at the same time. So, and locking and blocking is something which you can, would say, you can, so the transaction isolation level itself will determine the level of concurrency, and that is something you have to keep in mind. So the default transaction isolation level is read committed, and I will give you a short introduction about this because it is always good to understand the difference between the default behavior of SQL Server and the optimistic concurrency model, which is read committed snapshot isolation or a low snapshot isolation. So this is the default behavior. So I will create a table here within the AdventureWorks 2017, just inserting 2 records. It's pretty easy to understand what I'm doing, hopefully. And I will reset the weight stats, and I will show you in a minute why I reset the weight stats. So, and I will set a lock on a table because, again, when I'm updating a table, I will set an exclusive lock on the resource. In our case, this is the RID, the record identifier, because it is a heap. So let's do it. We do not commit or roll back the transactions. That means the transaction is still open. So when I now try to read the data I'm currently updating in this session, in another session, that is a normal behavior of SQL Server. That is read committed, the standard transaction isolation level. That means when we now identify the logs within the database, we can see that we have a block because we have 2 logs which are not compatible with each other. So we can see that the current session 88, we have a shared log, also a schema shared log granted, and an exclusive log which is granted because of the update. And in the other session, that is session 72, you can see it here on the spit, it is currently waiting on the intent shared log. You can see you have the information that the session is blocked by the other session because both logs are not compatible with each other. And that is something which definitely will harm your performance because the reader has to wait until the writer either rolled back or committed the transaction, right? So this is something which you will see in a busy OLTP system, very likely. So when you now try on the other way around, when you concentrate on long-running query, you're doing it wrong because the culprit or the reason why this query is waiting is the other query. So the select query is waiting on the update. There is no way to improve performance, I would say, by another database design or whatever, or in some cases, it is not possible to implement the right index strategy here. So therefore, it is not a very good approach to concentrate on long-running queries because long-running means you have an execution time, and the execution time is nothing else than waiting and running. That means your thread is running for 4 milliseconds, which is a quantum on the CPU, and this is what matters. The other time, the elapsed time, includes wait time, and that is what we can see here. When I now ask for the current weights, we can see that there is one wait type, which is log MIS, and that is exactly the wait type, the log which is currently waiting on the blocked session, right? So again, it is not a good idea just to concentrate on long-running queries without considering the overall context. When I now roll back the transaction on this side, the other transaction is done, right? We can read the data. And again, we can now use DMO's weight stats in order to analyze for which kind of wait types we are waiting. And that is something you need to understand. First of all, analyze your weight stats in order to understand whether you have locking and blocking issues. If it is not the case, it is not worth to think about pessimistic think about optimistic concurrency. So this is an indicator for sure, yeah, to decide to change your standard transaction isolation level. So now we talk a little bit about the read committed snapshot and snapshot isolation, which is the optimistic concurrency transaction isolation level. And as you can see here, the read committed snapshot isolation and the snapshot isolation have a lot of things in common. First one is you prevent dirty reads. Because I have seen a lot of application using no log or read uncommitted, right? Just to improve the performance. But this is really, really a bad idea because of several reasons. I do not want to mention them here, but the most prominent one and the most known is dirty reads. Yeah. So whenever you do not ask for a shared log, the other session can update the record and the other session will read dirty reads, right? That is something which you can completely prevent by enabling optimistic concurrency. And that is why it is that valuable to think about changing your transaction isolation level when you think about when you suffer from locking, especially blocking. So as you can see, the number of logs required by a transaction is reduced for sure. Writers do not block readers, yeah, but writers will still block writers. That is something which you cannot avoid. The only chance to avoid this is to go to in-memory OLTP. So fewer log escalation take place. I do not want to talk about log escalation, but it is a case, yeah, that it will reduce log escalation. Number of deadlock is reduced. And what you need to understand is whenever we talk about optimistic concurrency, we always talk about the version server, which is part of the TempDB, which means you have to monitor your TempDB very carefully, because otherwise it is very likely that you will see a lot of problems in your TempDB, right? And I have an example later. I do not know whether we have time to show it, but it is definitely something you need to monitor, your TempDB. Okay, this is something which we will see later, and that's it, because everything else we will see an example. So the difference between read committed snapshot isolation and low snapshot isolation is that the read committed snapshot isolation is a statement level snapshot based isolation, which means any query can see the most recent commit values as of the beginning of the statement. That is different to a snapshot isolation. Here we can see the scope is the transaction level, the overall transaction. And we will see an example later on. That is something which is different. But everything else, like the version tag, copy on write, everything which we will see now is common. It means we have the same problems and we have the same benefits. Yeah. So, and it is also worth to mention that the snapshot isolation is able to detect update conflicts. That is different to read committed snapshot isolation. So if you want to rely on update conflict detection, you need to use snapshot isolation instead of read committed snapshot isolation. That's it, I would say. So just want to make you aware about so-called transaction isolation problems of and these are mentioned here. So we are currently talking about the optimistic concurrency, and we can see that we do not have dirty reads, right? But we still have in a read committed snapshot isolation the problem of lost updates, non-repeatable reads, phantom reads. Whereas when we use snapshot isolation, we also prevent dirty reads, but we also prevent lost updates, non-repeatable reads, and phantom reads. Because again, the scope and the log is based on the transaction level. So that means as long as the transaction is open, all logs will remain. That is completely different to the read committed snapshot isolation. So you can compare read committed snapshot isolation to read committed, which is the default. The only difference, as you can see, is that you do not block, or writers do not block readers and vice versa. Yeah, that's it. How to enable read committed snapshot isolation? So it's very easy. First of all, we will execute in another session because this is something what you normally facing. So the system is in use, the database is in use. It is something which I just simulate here. There is a session which currently owns the database, so therefore we have a log on the database level already. And now I'm trying to set read committed snapshot isolation on database level, right? So that will not work because we have a log. That is something you need to understand. You are waiting on a log, yeah, on a compatible log, because you want to change the transaction isolation level default read committed to read committed snapshot isolation. That will not work. The only way to make it work is to either make sure that you're alone on your PC, or you can say set read committed snapshot isolation on with rollback immediate. That means all transactions will be rolled back, and now it is SQL Server is possible to change the default transaction isolation level, right? Because it is another blocking situation otherwise. So when we now, we can check, and this is really something which is definitely worth to know. We have sys databases, as you can see, and within sys databases, we have a lot of attributes, and two attributes which are related to the session is the read committed snapshot isolation on and snapshot isolation state. Yeah. So currently the database, and this is something you also have to understand, you are replacing the standard transaction isolation level, which is read committed now with read committed snapshot isolation. That becomes your default. Yeah, it's completely different, as we will see comparing to a low snapshot isolation, and both of them are completely independent. You can either turn this on or off, or vice versa. There is no dependency between both, because I was asked several times, do I need to enable read committed snapshot isolation first before I can enable a low snapshot isolation? That is not the case. They are working independently, right? My problem is that it is for sure from a database level you can see it, but from a session level you will still get the information that the session is currently running in read committed. That is not very precise, I would say, because this is wrong, right? So you only have a chance to detect the current transaction isolation level from the database and not from the current session, right? That is something you should know. Okay, so enabling a low snapshot isolation, I will skip this because we are running out of time already. That is normally a session which takes, I don't know, 3 or 4 hours. So I just want to concentrate on a few things here. Copy on write. So the technology, and we will see it. I do not want to read what I have written here because I want to show what is going on behind the scenes. The technology which is used to enable a low snapshot isolation or read committed snapshot isolation is called copy on write. Copy on write means that you will send the current version of your record to the version store within the tempdb before you change it. Yeah, so that means whenever you do an update, whenever you do a delete, or for both of them, you will send the former version before the change to the tempdb, to the version store. When you think about this, that is the only way how a SQL Server now can ensure that blocker will not read, writers will not block readers and vice versa, because the reader now will get the current version of the record from your tempdb, from your version store. But on the other hand, you also have to understand that the tempdb is really involved in the overall mechanism. That means your tempdb becomes your bottleneck, because everything you're doing, every DML operation in read committed snapshot isolation and a low snapshot isolation means that you are sending records to your TempDB, which is a physical I/O, right? So, and I have an example here. We will see copy on write. So, and first of all, we want to understand the impact on update. Again, this is a DML statement. So just want to reset everything because otherwise nothing is working anymore. So just want to make sure that this is a reset, perfect. And now I create a heap. This is the default behavior. So, oh, sorry. Let's create a heap. And I will insert 5 million records. And first of all, let me insert 5 million records. So it takes, I don't know, 20 seconds. Hopefully. 12 seconds, not bad. So I will enable I/O statistics, time statistics, which is always good whenever you have to analyze performance issues. So I will reset the weights. And now I will update all records. And by the way, I didn't change anything. This is still the transaction isolation read committed. It is a pessimistic concurrency model, the normal one, right? So I'm updating all records. And it will take a while, almost a minute, if I can, no, sorry, almost 6 seconds, not 60 seconds. But you can see we have about 70,000 logical IOs. And yeah, again, it took approximately 6 seconds. So when I now analyze the weight stats, just to see what is going on, so there is nothing which really is, yeah, I would say, related to the update statement, right? So now this is just a baseline. Now I will enable read committed snapshot isolation. Now we have optimistic concurrency in place, which becomes the default of the session for the database. Just to make sure that it is working, yes, it is enabled. Otherwise, nothing is working anymore. And now I will repeat exactly the same example. I will clear the weight stats. And there's one DMV which we are going to use over and over again, which is dmtran version store, which tells me the page allocation of the version store within the TempDB. Yeah, so it will count the pages. So as you know, every record we will save will be saved in a so-called page, which is 8 kilobyte big, right? So currently we can see we do not have anything in our version store. It is not surprising, but just to make sure that everyone has the same understanding. So perfect. Now I'm running the update statement again, exactly the same update statement as before, but in optimistic concurrency. So we are already over 6 seconds, and this time it took much longer. If I understand correctly, it should take something about 25 up to 35 seconds, depending on, yeah, I don't know, on my laptop. Sometimes it's fast, sometimes it's not fast. So we have to wait. And that is something you already have to understand. Behind the scenes, all records, all 5 million records are now will be sent to the version store, to the TempDB, which is part of the update statement. That means you have a physical write into the TempDB, and that takes that long. It takes, I would say, half a minute longer than the other update statement. When I now query the version store with dmtran version store, as you can see, we have a lot of pages in our TempDB. That means our TempDB was growing because of the update in optimistic concurrency. Okay. So every record is sent to my version store. Then we have something which is the garbage collection. I do not know whether we have time to talk about later, but the garbage collection will clean up all these kind of versions within the version store. So it will release a memory in buffer, and it will also release the pages within the TempDB. So, and I will stop. You can see a lot of it will become 5 million, as you can already imagine. So when I now query the weight stats again, we can see that, sorry, I'm here. So we have a lot of page IO ledges, some here. We have page ledges and we have somewhere page IO ledges. Okay, in the other example, I had more, but these kind of page ledges, page IO ledges, so ledges overall is a mechanism just to protect the page because every threads which are running in parallel can update the same page from a logging perspective, but not from a physical perspective, because otherwise one thread will overwrite information within the page, which makes it impossible for the second thread to find the right place to save your data within the so-called payload. That is why we have page ledges in place. Page IO ledges means that we will read pages from the disk either to update or to read these kind of pages. So, and again, page IO ledges is an indicator for this scenario. So we are sending all the records to the version store, and therefore the database overall also will suffer from page IO ledges. So I will reset everything. Now we understand, hopefully, that we already have a big impact on update. Now let's see what happens when we talk about reading data. So first of all, I just want to repeat the settings just to make sure that everything is working. Perfect. So in the standard transaction isolation level, again, read committed, I'm creating a heap, same as before. I'm inserting 5 million records, and we know already it takes maybe 5 up to 7 minutes, 6 seconds. Yeah, let's see. This time it takes a little bit longer. Okay, that's okay. Again, I will enable the statistics. I will create a checkpoint and a DBCC drop clean buffer in order to make sure that all the updated pages, the so-called dirty pages, will be sent to the MDF file. And afterwards, I will flush all these kind of dirty pages, which are not dirty anymore. So that means all pages from our buffer cache. That means my buffer is completely empty. So when I now select all records from the test table, which consists of 5 million rows, it takes a while, but not that long. In the meanwhile, or no, not in the meanwhile, it is not working. I have to wait, honestly. Okay, it took 36 seconds before. We have to wait, but I guess just for another 10 seconds.
I found sometimes when I do demos while I'm connected to a Teams meeting that the Teams or Zoom or whatever it is steals some CPU as well. So it usually takes longer to demo when you're doing an online presentation.
That's a good hint. Yes, you can see it takes a little bit longer than the last time, but I think I would say 44 seconds is still, I would say, we can wait for, right? But you're right. It's a good hint. So first of all, we now understand it took 44 seconds to read 5 million rows in our standard read committed transaction isolation level. So, and you can see that we almost read, so approximately 70,000 pages, right? So nothing we can do better. It's just a table scan over all records. Now I will enable read committed snapshot isolation. So we are going to the optimistic concurrency. And just to make sure that everything is working as expected, perfect, it is on now. I will reset the weights and I will do exactly the same as before. Why I'm doing it, 1 second. Yeah, so now I'm updating the record, and because I'm updating the record, all 5 million rows will be sent to the version store. And now I'm reading, and that is something which I can do with optimistic concurrency, which means blockers or readers will not block writers and vice versa. So let's do the following. I will update the statement here, run the statement here, and before I will copy this over to another session. Let me close this one, otherwise it's a little bit confusing for me. This is something I need to close. Perfect. So, and for sure, this is something which I cannot run within optimistic concurrency, right? I cannot update and read at the same time for the same resource, right? Let's do it. It is now possible. I'm updating, and when the update is done, again, it takes something about 30 seconds. We will run the other select statement in the other session. Honestly, I do not even have to change the session, but that's fine. No, I'm still, I need to because I'm still in the transaction. That is a reason. I just also want to demonstrate that you do not have any kind of blocking resources here. So again, it will take something about 30, 36, if I remember correctly, seconds, maybe a little bit longer. But now we are creating versions of your record in the TempDB, as you already know from the update DML statement. When I now read the data again in the garbage collection, and this is something why that is a reason why I executed the query directly after the update.
I lost the audio of you. I don't know.
Is this better now?
Yeah, it is.
Okay, sorry. I don't know what happens. Okay, no worries. Then I will repeat it. So we updated all records, all 5 million records, and therefore we have versions within the version store. And you can see that the read performance is slowing down because now we have to go from the original page within the AdventureWorks database, and there is a so-called version tag, a pointer to the TempDB. And within the TempDB, now the page is, you can see it here, the page is red. So, and we can see that before we had something about, I don't know, 7,000, something like that. Yeah, and now we are reading about 6.5 million pages. And that is why the select statement is so much slower, because we are reading from the original page and from the former version of this page, which is part of the TempDB. So you understand that we have already an impact on update, and we have an impact on the select statement, right? That is something you need to consider whenever you decide to change your transaction isolation level to an optimistic concurrency model. We commit that one just to make sure that I do not have any kind of open transaction, and I will do some housekeeping. So now let's talk a little bit about the version tag. I already mentioned this several times, and I will show you how it works. So to disable everything. So we are again back in our to our transaction isolation level read committed, the standard one. Perfect. I will create a table called before RCSI, but the name is not very important. I'm inserting just one record. And what you can do is you can allocate the page within the so there's several ways to do it. I decided to use sysfn syslog cracker just to find the page. And now we are dumping the page. This is a file ID I do not need to change. The AdventureWorks database, perfect, and the page ID. Every page can be addressed like that. Database, file ID, page. And then we have different kind of print options. So that is the page on the it is a page on the MDF file, make it very easy. Yeah? And you can see that we have a record size of the record which we inserted, which is 11 bytes. Pretty easy, because if you can see, it is the so-called fixed length column. An integer have 4 bytes, and we have 7 byte overhead. Take A, take B, and so forth. That is, you always have 7 byte overhead whenever you insert a so-called fixed length column. That will change or become even more 4 additional bytes for every variable length column, which is varchar or whatever. But that's not that important. But first of all, just recognize that we allocate 11 bytes for this record. For every record we are inserting, we allocate 11 bytes. Perfect. So when I now enable the read committed snapshot isolation, just to make sure it is working, yes, it is on. And sometimes it takes a while to enable, and we already know why, because SQL Server have to roll back transactions. But someone from the audience asked me, so is SQL Server already creating the so-called version tag within every page whenever we enable read committed snapshot isolation? That is not the case, because we can see that the page ID is still the same. So, and when we now go to the page and dump the page again, we can still see that the record size is 11 bytes. That means SQL Server didn't implement anything by just changing to changing the transaction isolation level to read committed one. So, but now, after we enabled read committed snapshot isolation, we will insert another value. And again, normally it should allocate 11 bytes, as we know already. So I just want to make sure that I'm dumping the right page. Let's dump the page again. And we can see, let me blow it up a little bit. So we can see here, the first record allocated 11 bytes, and the second one allocates 25 bytes. So this is a big difference. So enabling read committed snapshot isolation or optimistic concurrency will allocate 14 additional bytes within every record whenever you change the record by a DML operation, which is the so-called version tag. It allocates, or it allocates 14 additional bytes. And this is really important to understand, because we will talk a little bit about page splits, and we will talk about ghost records and so forth directly after this. So, and that is the reason why SQL Server have to reorganize the payload, because again, it needs 14 bytes additionally for every record which is in the page. Otherwise, this kind of mechanism, copy on write, is not working, right? So in the version tag information, you can see here, so there is a version or the transaction timestamp. That is a time in, I would say, transaction time, yeah. The change happened, but currently we do not have any kind of former version of the records. The version pointer is still null because we didn't update the record so far. We just insert a new record. So this is something I can skip, I guess. When we now update the record, let me do the following. I will change this command, or I will bring it, because of we are missing a little bit time. I will update this table, and hopefully it works. Yeah. And now, hopefully it is the right record. Otherwise, I need to see what is in the table. Yes. Now we can see we updated the second record, which we inserted before. And we can see now that there is a version pointer placed in the payload. And that is the address of the former page for this page where the update happened, right? This is the address to the tempdb. It's pretty easy. We can easily dump the page from tempdb if we like. Tempdb file 3, as we can see, and there's one page. That is a page number. We can see this is the former version of the record, right? This is the page. Sorry, I missed the print option. Yeah, now we can see a little bit more. The problem is that it is there are different reasons that you cannot really dump a page from the tempdb, but believe me, we can see already that the page exists, and that is where the former record is now located, right? So let me reset everything, and let's talk a little bit about the impact of implementing a forwarding record. Again, we will implement a forwarding record whenever we are in an optimistic concurrency model and we are updating or delete a record. Also, this is also true for deletion, right? Because the former record have to keep until the other transaction still needs the information from the current, from the former record. So let's do the following. We will change again back to our standard behavior. Yes, perfect. I will create another table. This time I'm inserting 12 records. We are allocating 6 bytes, pretty easy because, yeah, it's okay. We are allocating 6 bytes. So now we can use another function which is also officially documented, which is this DMDB database page allocation, and we can dump the pages which belongs to the table. We can see 6 pages currently belongs to the table, and they are currently allocated. We have more because of the extent, but only 6 of them are allocated. Let's dump the first page. And the first page, for sure, it always change. This is not predictable. We can see we do not have any kind of additional version pointer in place, right? When we go down, 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 we have this first record and we have the second record, and we can see there's nothing like a version pointer here in the end of the record, as we have seen already. That's perfect. So now we enable read committed snapshot isolation. And again, we create a heap. Yeah. So we are currently talking about, just to remind you of that, we're talking about forwarding record. And forwarding record is something which only happens in a heap. That is the reason why the table is a heap. So after enabling the read committed snapshot isolation, just want to make sure it is enabled, because otherwise nothing is working anymore and we have a lot of fun, or I have a lot of fun. So now I'm updating all records of the first page, the page which we already dumped, right? So when we now ask SQL Server for the page allocation for the heap which was created, and before we had 6 pages, we can see that we have 9 pages. So SQL Server have to allocate 3 additional pages just because of the update. Why? I will tell you why. When we dump the page again, we can see that because the payload is restricted to, let's make it very easy, 80-60 bytes, right? So we can already understand that it was not by chance that I have a table definition like this. This is a table again. This is a table definition. We have an integer, which is 4 bytes, and we have additionally 25 bytes with an overhead of 7 plus 5. But you understand that when we double the size, when we insert 2 records, and now we have to insert 2 times 14 bytes additionally for the version pointer, so for the version tag to the tempdb, there is no place left. That means SQL Server cannot use the same page anymore because the space is limited and already full. That means SQL Server have to allocate a new page. And because of the index balance tree, which non-clustered, which will look for the appropriate and missing non-covering columns in the heap table, SQL Server has something which is a forwarding record, because the forwarding record is now an address. I will show it to you. It is an address to the other page. Now I need to go down, 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 down. Here we can see we have the version temp in place, the version tag in place, and we can see one record is forwarded to another page. Yeah, and again, SQL Server will not split the page because we are not in an index. SQL Server will keep an address of the original record within the original page, but will address the SQL Server storage engine to another page to read the missing page and the missing record from the other page, it will come back. So forwarding record is something which you definitely should avoid, because you're creating more and more IOs, because you're reading the page. SQL Server will be addressed to another page and will jump back and read the page again. So that is something you should avoid. Forwarding record is, I would say, from a performance perspective, I would say comparable to a page split, but because we are not on a balance tree, we are on a heap level. We do not have page splits, but we have forwarding records. So that is something you need to keep in mind when we talk about forwarding records. For sure, now we can dump or can go to the other page to see the missing information, but this is something I do not want to do. But there is a DMV which we can use. This is this DB index physical stats, and from here there's one information. I just bring it to the beginning of the result set. It will count the forwarding record, right? So, and that is why you always have to ensure, whenever you talk about the index rebuild reorg job, you also have to consider heaps. That is something I do not see very often, and people wonder why the read on a heap will take that long, because you create additional pages and all of them have to be read. So when I now rebuild the table, and that is the only chance to do it, we get rid of the forward record. And the page allocation again is 12, right? It is even more than before, but the version tag is already implemented for every record now. And that is the reason why we do not have 6, we do not have 9, we have 12, because there's only space for one record on every page. But it is far better than jumping from one page to the other and back and read again. So let's talk a little bit about page splits. And we are now in an index, because again, page split only is possible within a balance tree. We can have it on a leaf, we can have it on the intermediate level, and even on the root page. So let's create a table pretty much the same as before. We are inserting the same records as before, but this time the difference is we are creating a primary key, and primary key per definition is it is a unique clustered index, right? It's not always the best decision to cluster your primary key, but let's keep it like it is. So this time we will ask SQL Server again for the number of pages, and we can see we allocate 7 pages, a little bit overhead because of the index. And when we now get the statistics from index physical stats, we can see that we have an average fragmentation in percent here on the leaf level. No, this is the leaf. Yes, that is the leaf level, about 16%. And we have a physical fragmentation of 99%, which is almost perfect, because every byte or bit is allocated within the page, right? You will never ever see 100%, by the way. So when we now update the first page, the first 3 pages, same as before, I will ask SQL Server again how many pages are allocated to the index. We can see this time we have 12. We have also 3 additional pages here. So let's dump the first page. And we can see that this time, hopefully we can see, I do not know whether I have the right page in place, but I think so. We can see we have a version pointer in place, perfect. And we have, yeah, okay, that is perfectly fine. But in the, we do not see the page split address here, because this is handled by the so-called W-link chain, right? But again, because we implemented 14 additional bytes for the updated records, the index is now fragmented. So let's do it. Let's ask SQL Server again for the logical and for the physical fragmentation, and we can see the physical fragmentation is not near to 100% anymore, and the logical fragmentation is 66%, which means we do not have a sequential IO read anymore. we have a random I/O read, which is in terms of the SSD and buffer, not, I would say it is not a big problem anymore, but you can see that we are wasting space. So we have only an average allocation of 66% of every page. That means we have to read 1/3 additionally, right? And no, the other way. Yeah, we are reading 1/3 additional pages, and therefore we are wasting 33% of every page on average. So that is also something you need to keep in mind. By rebuilding the table, we can see that it is now gone. The index physical fragmentation is again almost perfect. That is a reason and that is something you should consider. It is not only the TempDB which suffers from optimistic concurrency, from the optimistic concurrency model. It is also that you will see a lot of page splits. You will see a lot of forwarding records, and another thing which is called ghost record. And I have another 8 minutes. I'm pretty sure I can cover this. But it is not for free. If it would be for free, SQL Server will implement read committed snapshot isolation as a standard transaction isolation level. That is not the case because of that, right? So let's do some housekeeping here. And let's talk a little bit about ghost records. And honestly, I was surprised to see ghost records on a heap, because ghost records is normally what you can see in an index, in a balance tree, because SQL Server will, I would say, mark a record within the balance tree logically as deleted, and later on the ghost record cleanup process, which is running from time to time in the background, will delete all these kind of logical deleted records within the balance tree, because it is horribly expensive to roll back a delete transaction on a balance tree. That is the reason why SQL Server or Microsoft decided, first of all, to mark the record as deleted. And when you now roll back your deletion, SQL Server just have to update the flag and do not bring all the records in the right order and rebuild the overall balance tree. But again, ghost records is something which you normally see just on indexes, never ever on heaps. But there's an exception: read committed snapshot isolation or optimistic concurrency. This is also true for low snapshot isolation. So we will create a table this time. We will insert 4,000 records, a little bit more than before. So, and we are in a heap, right? I do not created any kind of index so far, but again, so just to make sure that everyone has the right understanding, it's still a heap. But for sure, we have an average, a logical and a physical fragmentation, or the other way around. In this case, it's the physical and the logical fragmentation. We do not have any kind of ghost record, and we have 19 pages, not a lot, but we have. We will disable the ghost cleanup process, which is never ever a good idea in production, but for demonstration. So there's a trace flag. Good thing, enable the trace flag and leave the company or go to holiday, so your colleagues will have a lot of fun. So we delete all the records, and once we deleted all the records, we can see from a page allocation, we have 26 pages now in place. And when I now dump one of the pages, for sure, we can again see that we have a version tag in place, but we also can see, we also can see that we have a ghost version. Here we can see the record type is called ghost version. And there's one information in tag A and there's one information in tag B. So SQL Server have two information within the overload of the so-called fixed variable length format in order to identify whether we have a ghost record or not. So you can already understand how important the ghost record is, right? So SQL Server spends 2 bit for it. And when we now go to the end, first of all, for sure we can see the version pointer, and we can see that. What should I see? No, and for sure the length. So that's perfectly fine for the moment. And again, the version, the ghost record, the flag will now force SQL Server to overread these records whenever I select the record, because they are not there anymore from a physical perspective. But when you think about the optimistic concurrency, it should be there, because this is a former version which was sent to the TempDB, and you need to have a version tag. So therefore, you cannot physically delete the record, because otherwise there is no address anymore to the TempDB. When you delete the record, there is no possibility to jump to the appropriate page, to the appropriate record within the TempDB. It's not possible. That is the reason why SQL Server have to keep the records and just mark them as ghost, right? And okay, this is something I can skip because we are running out of time. Let me rebuild the index. And okay, before we should see a lot of ghost records. Now they are gone, so I skipped that part. Yeah, sorry for that. But when you before I rebuild the table, we should see a lot of ghost records. Here, 4,000. All of them were marked as ghost record. And then it was my mistake. I rebuilt the table, therefore the heap, and therefore SQL Server will rearrange the pages and get rid of the ghost records. Okay, so honestly, I guess we only have 3 minutes left. I think it is not a good idea to start with a new example rather than giving people time to ask maybe questions about optimistic concurrency, because you can see I'm only 1/3 through, and I already deleted a lot of examples here because I already know in advance that I'm not able to deliver all of them. So I guess it is maybe better to spend the last 2-3 minutes on questions.
That's a good idea. I have no questions in the chat, but I have one from myself, which is in SQL Server 2019, we got the accelerated database recovery.
Yes.
Which is kind of a version store inside the user database instead of using TempDB for it. Will that one be used? Will that version store be used also for optimistic concurrency in that case?
That is a good question. Honestly, I was already trying to understand how accelerated database recovery works, and honestly, it is so super complex that I decided first of all to concentrate on other topics because again, it really melts your brain, yeah. So, but you're completely right. Accelerated database recovery. My understanding is the same. So when you read the SQL Server 2019 online documentation, there is already a hint from on the page read committed or optimistic concurrency to accelerated database recovery, and SQL Server or Microsoft tells us that this kind of technology will replace the TempDB version store. And because of the mechanism, which I'm not able to explain, it should be also much faster. Right? Okay. So that is something which is worth to implement. But again, this is your decision. This is not on by default, accelerated database recovery. But because I guess there are also, as always, some kind of benefits, and there are also some kind of drawbacks, which you need to know before you enable a setting just by enabling a setting.
I mean, one thing could be if you have multiple databases and they all have lots of transactions and you want to test optimistic concurrency and see if it helps at all, at least you can get rid of some of the TempDB contention if it's moving into the user database. Then what I would like to explore is if I could put maybe the version store on its own file group or something like that, so I can move it to another physical storage or
you're
whatever.
right, but you're completely right. So you, I would say, you eliminate the problem on the TempDB, but you still have the problem by, I would say, maybe doubling the logical IOs, and also you have copy on writes. This is still a mechanism, for my understanding, which is still in place when you even enable accelerated database recovery. But again, do not ask me any details about it. It was already so complicated to understand the redo and undo phase of the database in terms of recovery, because this is the first topic you need to understand before you dive into accelerated database recovery, right?
Yeah,
But
true.
yeah, I'm working on it, let's say.
Good. Just shout in social media or something if you come up with something.
Yeah.
I'd be really interested. I might
Sure.
explore some myself. I have a question from I don't know if it's Jens Herman or Herman Jens, but the question is system outlocking problems. Would you say it could be a bad idea to enable RSCI? Long-running jobs with many writes could get slower. Am I right?
Yes. So the longer the transaction is open, the longer the garbage collection have to wait in order to clean up the version store. That means the higher the probability is that your TempDB is growing and growing over time. I have an example here, and it even becomes more difficult, and you will even suffer from more performance issues because you will see something which is a chain. You will create a chain, right? So because in a low snapshot isolation level, low snapshot isolation, transaction isolation levels, sorry, SQL Server have to keep all versions of a record for the duration of the transaction, not on a statement level, which is a different to read committed snapshot isolation level. So therefore, in a low snapshot isolation level, when you enable that, or you decide to execute your queries with this option, with this transaction isolation level, you will end up with a chain of different versions from the first update until the last update. And the longer your transaction takes, the longer these kind of records will keep in TempDB and also for sure in memory, because we are talking about the buffer cache for sure, yeah, data cache.
Yeah.
Shorten your transaction. That's definitely the key.
Mm.
And that is something which you also can do by implementing the right indexes, right?
True. And I mean, my take on many things, if there's a technology that you think, should I use it or should I not? If it's a technology that is addressing blocking, if you don't have a blocking issue, don't
Never
implement it.
Exactly. And that is the reason why Microsoft decided to go with a read committed snapshot isolation, because it is a good balance between these kind of transaction isolation problems, right? We talk about dirty reads, non-repeatable reads, and so forth, and the overhead, yeah. And I guess when you really suffer from locking and blocking, it's a good idea to implement it and give it a try. Yeah, never ever enable on production and go to home. That's not a good idea.
Holiday.
Yes, yeah, it's perfect. Yeah. So and do not inform your colleagues before. That's really good. But if you really suffer from blocking and locking, I think maybe in-memory technology is something which is, I would say, more appropriate to implement, I would say, yeah, because it's lock latch free.
Yeah, it's like almost magic when you see the speed of just doing inserts and updates with
in memory OLTP, you mean?
Yeah. I mean,
it
I
is.
thought when I saw a demo first, I thought, okay, this is fast and all, but I would like to have the data persisted. But it was, of course, persisted. It's just that it's a streaming mechanism instead of the page allocation stuff. So
yeah, you do not have a page anymore. You just have records. That's for sure. But also only, I would say, my recommendations, think about in memory OLTP only when you suffer from latches, especially latches, yeah, and locks. So then it is really worth to implement in memory OLTP. Yeah. Otherwise, there are other reasons, but I would say this is the first question you need to answer in order to decide to implement in memory OLTP or not.
And the thing within memory OLTP, usually if you have a large contention, it's because you have lots of transactions. That usually means you have a large data volume as well. So it's going to be expensive in terms of RAM if you want to go for in-memory OLTP, usually.
I think it's not a question of the data size. It is more or less the number of concurrent threads. Yeah, because you can deal with terabytes. For sure, it is very, or the other way around. So if you have just a small table, which becomes your bottleneck because a lot of threads will write into the table concurrently, then this is a good candidate for in-memory OLTP. And Microsoft allows us just to implement in, I would say, a specific table and make it in memory, yeah, and maybe stay with the traditional approach with all the other tables, right? That is something which you can consider, right?
Yeah. I'm gonna go and break the discussion now because I have some meetings for my paid work as well. But I'm reading from the chat. Marcus Persson is saying thank you for a great presentation, Torsten, and thank you from myself as well. I think it was excellent. I love the demo intensive stuff. No PowerPoints, that suits me perfectly.
Yeah, we can do another session if you like. So yeah, let's chat about this.
Yeah, I'm gonna try to find which screen I'm gonna share, which is this one. And just briefly mention before we break up for today that on October 17th, Data Weekender is coming back. It's a conference that I was organizing together with some friends on May 2nd, and we're going to do a sequel of it on October 17th. So just go to dataweekender.com or join the meetup to get more information about that. Another thing which is happening right now actually is this thing, New Stars of Data. It's going on today. They have a lunch break now, but in a little less than 2 hours, it's starting again. So go to newstarsofdata.com, check out the schedule, and join the fun. What's special about New Stars of Data is that they have only new speakers. None of the speakers have ever spoken on a conference before, so it's pretty cool. They have had mentors, like really experienced speakers who help them put together the presentation and do a test run and so on. And those mentors are also moderators or co-moderators in the session. So I've been watching a little bit of it before lunch, and I'm gonna check out a few sessions after lunch as well. So from 3 o'clock Central European time, they start again. That's the marketing session for today. Thank you again, Torsten, for joining. And for the rest of you, the next week we will have Alex Yates talking about deploying database changes without any downtime. So that's going to be exciting too. Thank you, Torsten. I will see you around.
Yeah.
Okay.
Welcome. Cheers. Bye.
Bye.